Okay, hi guys. So happy to be here to share with you how to do a bit of something what we call data labeling. So this works in a scenario where, let's say we have a lot of data and we want to train a machine to uh, classify the data. And then we realize one of the issues that we come up with very frequently is that we don't have enough annotated data or data with the ground truth labels. So one of these ways we can do it is we can use a bit of data augmentation techniques. Uh, this is one of the ways I found that would be quite useful because it's done in a semi-supervised manner. So let's get to it. So first and foremost, you would have, I'll use an example using this data from uh, this paper, Automated Hate Speech Detection and the Problem of Offensive Language. They have a very nice data set here that I'll be using for my particular demonstration itself. So I've uploaded the data into my CSV file and I cleaned it a bit into something called a sample data and an unlabeled data. So what is a sample data? So this is what a sample data will look like in the Google Sheets. So essentially, let's take the scenario that I have labeled some of the data. Um, as you can see here, I wouldn't label a lot of them. Let's say I have hate speech, offensive speech, and speech that are neither offensive nor hate speech. So this will be a bit triggering, so be mindful of that. So these are the types of speeches out there. You realize I've taken a subsample, a very, very small sample of it. The actual samples that was used to train machine learning classifiers will be way, way bigger than this. But let's say in this scenario where you don't really have time to uh, crawl through the whole thing by yourself. So what you can do is you can get the machine to assist you in a certain manner. So what you can do is you find exemplars for each category. This is something from the qualitative research. You find an exemplar that represents the particular theme you're looking for. So you might find a particular text that you think represents the idea, that is an exemplar of the category of hate speech. So you can add this in so that the machine can learn how to recognize hate speech from this. So this is one way of doing it. So I wouldn't say that's the best way that to do things. There are definitely different ways of augmenting the data or to quickly help you get more data. But this is, after all, a presentation on data annotation. So I'll just go straight into the weeds. All right. So first and foremost, let's look at this. Okay, so we're gonna first mount our Google Drive. Let me reset everything. Maybe it'll be easier. Okay, let me first okay, yeah, so I'll run my Google Drive. Connect, yeah, and yeah. So here we go. Once it's mounted, I'll load these things. These are the libraries, which will contain the code that will be very helpful for what we want to do later. So we don't have to write the code ourselves. So with pandas, you can read CSV, but it doesn't necessarily have to be a CSV. If it's an Excel file, it is an Excel file. You can try. You probably change the. It'll become pd.read underscore Excel. So depending on the use case, you may want to change it accordingly. Okay. Yeah. So that was a bit of lag here, but and you can see it was loaded. They loaded data. As you can see with here and the text and the label. So one of the things you want to do is to do this. Okay, do this. And we'll see how many are there in each category. You want them to be relatively, you want them to be quite close to each other in terms of the balance. Because if you have something that's severely imbalanced, the machine may actually end up predicting something else altogether. So what I mean is, let's say if you have 20 of this, and imagine you have one of neither and you have one of inoffensive speech, the machine may just decide, okay, the best way to get the highest score possible is to just predict everything as hate speech, which is not what you want out of your machine learning classifier. What you want it to do is you can give it a text, then it will predict any kind of thing that you want it to predict. That means it will give you a proper and correct label for whatever text that you feed it with. So you run this. So this one sorts it by according to the label. And then vectorize, it's because machine learning machines cannot do one thing very well, which is they really can't deal with words, but what they can do really well with is with numbers. So what we'll do is we'll convert each and every label into a particular number itself. So when that happens, the machine will have something to calculate towards a prediction, which is in a number 0, 1, or 2 in this case, because there's only three categories. So if you see here, X and Y comes from the convention of regression. So you have an X and you pass it through a function, a classifier or a function or a particular algorithm, and then you have an expected Y as output. So that the Y, if you notice here, is a small y to represent that it's a predicted output. This is convention actually. So you can name it anything you want, but conventions are there for a good reason. So you can see they have all the text here, and then in the case of Y, you can see that they have all the predictions in the zeros, ones, and twos. Okay. So some of the things you want to do to increase the accuracy of our classifier is to do a bit of pre-processing. Because for this one, we'll be using a logistic regression classifier to classify the text data. Of course, there's better algorithms out there, but this I'll cover in another video. So this is the things you want to get downloaded. Then you have this thing, this particular function for cleaning the text. You just run this for now. For this particular purpose, I would prefer to use a lemmatizr rather than a stemmer. The nuances of each, I will go into a detail in another video. But essentially, for now, I will just want to clean the data so that I can remove some of the noise. What I mean by noise is that, for example, this is the text, like say, this movie is not based on the Bible, it completely leaves Christ out of the movie. But if you want to classify this as a particular kind of movie type or a particular kind of genre of movie, the actual thing that is really relevant to anybody's classification of that particular piece of text is probably not the word this is not, this is and not, and also it. These are not very useful words. That's why they're known as stop words. So as you can see here, when you clean out, so when you use this function to clean, you clean up a lot of things, such as stop words, and you see that it will actually put it to lowercase. And lowercasing is a way of reducing the dimensionality of the data set so that it will make it easy, it will make the classification more accurate, because after all, for cases like Christ, if there's a big letter C, small letter c, you probably would all mean the same thing. So that's in the context of a natural language context, or a movie with a capital letter M or small letter m, they probably will mean the same thing. So you don't want, but to the machine, it will be two different things altogether, because the differences in the capitalization will mean that it's a totally different object to the machine, or a totally different vector to the machine. So it will probably be represented in a different number. So you don't want that. You probably want them to be in the same number. So what you do is you put in lowercase. Again, all these things I will go into detail in a separate video. Okay, this is actually a practice thing. So I'll just run through this to do things and explain what each and every component does. So at this stage, this is to split the data. This is from train test split. So what it does is split the data in the test size. That means 20% of the data is for testing, 80% is for the machine to train on. So this is a way of for us to understand, roughly speaking, how is the machine performing. So because what you do is the machine learns on 80% of data. For the 20%, it has never seen it before, and then it will learn from them. So it may be able to learn something interesting. So you can tell roughly how you do on unseen data. Okay, then you can run this. And as you can see, what it does is we clean the text, and then we'll do something called count vectorizing. So we essentially, we just change it into numbers, but we change the text over here into numbers. So so this is one of it. Maybe if I can show you what it looks like. Yeah, so you can see it's a matrix, it's a sparse matrix of numbers. I think that's the best way I can describe to you without showing the whole thing. I probably need to Google like how to show you this whole thing, but for now you have take what I say as the truth, that this is a matrix of numbers for every single text that we imputed in. So this is not particularly useful, so I'll keep this. Then we run this. This will help us create a confusion matrix, which will be really helpful because we want to see what's the differences between what the actual data truth is and what the machine predicted as. So it'll come in handy later. I'll show you. So you run this and then you run this. This is a way of making sure that your report will have the proper things. So if you run this, so this is the part where the machine trains on data and then it gets the results. It outputs the results to you, like what's the accuracy. So as you can see here, the accurate. Usually people will use the F1 score. It's a good shorthand way of saying that it's probably around 60% accurate. That means if I give it 10, let's say there's 10 different texts, I can give it 10 different texts and it will be like 60% accurate. 6 out of 10 of them will be roughly correct. Then you can break it down to individual categories. So you can see if in the case of hate speech, 2 out of 4 times it was correct. In the case of leader, 3 out of 4 times. Yeah, then same for offensive speech around there. So just keep a lookout on the F1 scores because that's a way of noticing whether this is a good classifier or not. We can use a bad classifier for now because this is after all a semi-supervised way. We're trying to increase our data because the more data that we have, actually the machine will perform better. So this is one of the ways to quickly find ways to add to your data. All right, then now we run this. This is a confusion matrix. So it's very interesting. If you can see 0, 1, and 2, so it corresponds with 0, 1, and 2. So in this case, something was given as hate speech, but then it was there were 4 items that are hate speech. 2 of them were predicted correctly. 2 of them were predicted as offensive speech. Not very surprising because they are quite close in nature to each other. So therefore, you can see this is how you can understand that, okay, how well is your machine doing in a scenario where it has no experience with the data before. So this is one very interesting way of essentially training your machine to classify the data better. Okay, and we want to save this model as an LR model. So this is one way of doing things. That's my preferred way. There's many ways to skin a cat, cut a cat, or eat an elephant. Okay, so there's other machine learning classifiers I can use. I will just do them for demonstration. One of them is AWS. So you see the accuracy differences won't be that much. That is because it's really a small data. But this is a demonstration. This is to show you like how we can start to kickstart the process of adding more data. Then let's say if you want to diagnose your problem with the labeling, maybe you want to see what is the machine predicting wrongly. Then you can look at the data again and see, oh, okay, maybe there's the reason it's predicting this wrongly is because there's not enough examples. So label 0, label 1, these are one of the ways you can do things. And if you want, you can export it to a file. And then if you want, you can open that file and read it again so that you can get understanding what's going on. Then you run this. Okay, so this part enables you to label your topic. So you run this, and essentially this is what the machine is doing. So I'll just show you what it does. So for example, let me key in a particular thing that I have no idea. I hate pineapples. This should not be hate speech. So that means it should not be 0 or it should not be 2. So let's try this. Okay, so you got I hate pineapples is classified as hate speech, probably because of the hate itself. So that's one way of knowing that, okay, the machine may not be doing so well, but maybe we can try this. Pineapples on country X. Yeah, so it's predicting a lot of things at 0. Bias, maybe. So you can see this machine classifier isn't very good. So, but sometimes it may be accurate. So maybe I don't know. The movie. So yeah, so maybe what we have ended up creating a classification for was probably a hate words classifier. So yeah, but you can see if you change the words, it will give different predictions accordingly. So then another thing it does is it can assign probabilities as to how much it thinks if this particular text belongs to a particular category in terms of percentages. So 33% was 0 for the category 0, 46% for the category 1, and 20% for the category 2. So this is interesting. It's in a way of, I know I'm probably like not understanding this properly or misquoting something, but it's probably a representation of the machine's confidence in its prediction of this particular prediction itself. So, okay. So what does this got to do with anything? Okay, so one of the things you can do right now is you can use a classifier like this, and then you use it on unlabeled data. So you can get some preliminary labels that you can use to augment your data set. So I'll show you here. You run this, and then you run this, then you run this, then you run this, and then you run this. All right, sorry about that weird cut. Okay, sorry about the weird cut. So just to recap again, once you've clicked all this, I'll explain what this does. One of the things you do is over here, you take unlabeled data, as you can see over here, there's no labels. The next thing you do is you filter it. So that means you want to make sure that whatever is in here is not what we have used to train the data before. So this way we can be assured of the fact that we are labeling new data. So this part will label the data. As you can see, it will run the thing very quickly, and essentially because logistic regression is a relatively fast algorithm as compared to other approaches out there. So what it will do is it will give you a prediction and a range of probabilities which the machine is confident about its classification. It will distribute it from 0, 1, and 2. So if you want a case where you have to uh, completely discard everything. So just like here, they have the case of they want to label hate speech or inoffensive speech, or the case where there is neither hate speech nor of inoffensive speech. So there is a bit like a garbage can category where you use it to capture things that is not what you want to analyze. Okay. So the next thing you want to do is you do this, step, which it will tell you which is what's the maximum probability. So rather than read the whole list and try to figure out which one, so this one will find out the largest number associated with this particular topic. And then I map the labels over because I found that it might actually be helpful for people is that they have the actual labels here. So what then the next thing you can do is to export it in the new Excel file or CSV file. So if you want to export to Excel file, we just to Excel. And Excel. So this is one of the ways you can do it. So the next thing you can do is, let's say if you only just want to focus on particular subset, then you can run this. It will filter by all those with the number ones, and then you can export this accordingly. So I won't do this for now. I'll just do this. So one of the things, next thing I'll do is I want to use the data here, and I want to add it to this data so that I can train the machine to be a little bit more effective and effective in classifying the data. So what I will do is I will probably and then I'll run this. Yes, so it's here. So you can see there is a lot of text with a label and then the maximum critical probability. So one of the things you probably will want to try and do is probably to sort this accordingly. Sort this from the biggest to the smallest. Then one of the things I'll probably do next is to maybe filter, yeah, maybe filter for particular category to add first. Maybe I will look for the hate speech category. Okay, looks about right. Then what I'll probably do is I'll probably like select some of them. And then I will create a secondary file for that. And maybe let's create a new file. Copy. Maybe I will name it number 2 because this will represent the ones I collected quite a sizable number. So I have this. I want to do is I want to read through all of them and check that they actually correspond to the labels properly. Then I will do this. Maybe I select 10 of them. Try them here. No, this is not the right one. Let's go to number 2. I'll add them here. And the category is hate speech. Okay, so then maybe I will look here for either category. Then maybe I'll look about RA. I'll select 10 of them because you want it the data to balance rather than to label everything as a particular category, which is not what you want. After all, a machine that only just predicts everything as hate speech is not a good machine. A machine that can discriminate between hate speech and non-hate speech is the one that is quite good. So this is for the neither section. Now for the offensive speech section. Okay. So this one. And over here would be offensive speech. So now with this, what do? We can one of the things we can do is, because the first machine classification was classified on a not very good classifier, and we have checked and we realized, okay, these are what we found to be accurate and what we want. The next thing we do is we go back to here. Now we load labeled data 2. Okay. Then we run this. Sorry, underscore 2. Run this. Oh, it's a G sheet. Never mind. I'll do is download CSV file and re-upload it again. Yeah. Okay, sorry about the weird cut again. Yeah. So what I did is I downloaded the sample data 2, uploaded it again. Yeah. So now it's data sample labeled data 2. So next thing you want to do is, you can see it's over here, I guess. Yeah. So I'll copy this part. This is the one where we have added new data, more data to it, to our original late sample. Then you run this, run this, run this, and then you can run this again. There's a bit of, yeah, if it's not fully balanced, it's okay. The thing is, what I understand is from the literature is when it's really considered imbalanced when it's really, really drastic. Like the ratios are like 2:1, that kind of imbalance. So you just run everything. Of course, if you can skip it, if you understand which parts to skip, but if you don't, you can just run everything again. Yeah. Here you go. Now you see, hey, look, just by adding a few more, the accuracy increased even more. So that's pretty amazing, right? Yeah. But again, we must be mindful. It's a very, very small sample, so it may perform really well, but we don't know how you do on a larger unknown sample. So that's why you probably want to increase your number of samples for training purposes. So you can see, okay, it's doing quite well. When you run this, yeah, you can just, I'll just run everything. Yeah, live being live, I'll just run everything. And we have talked through this before, so I wouldn't run through this again. So now what you can do is you can rerun the unlabeled again. So remember before you only took like the top few of every category. So now you can run this again. You take the unlabeled data, you filter out for the thing that you've already used to train your data. So now this is the new untrained data. Then what you can do is to predict it accordingly. So it's interestingly enough one way of quickly processing the data and using it to augment your data sets so that you can actually have a good classifier. Then you realize it's a very iterative process from there on. Usually my prescription will be you hit around 1,000 samples and your accuracy level should be at least above 0.7. Then it's pretty decent for a topic classification classifier. For some things like sentiment, etc., the requirement will be quite high. Yeah, and the more data set you have, the more data you have, it's gonna be a lot more robust in terms of its prediction and how confident you are of its prediction. Ta-da! And that's it. All right, that's all for today. Thank you very much.